Hi everyone, welcome to Java Techie. So after a bit of break, we are finally back with part 7 of our in-depth Spring Boot interview QA series. I know it took a while for me to get back to this, so thank you so much for your patience and continued support. I'll do my best to keep it going consistently from here on out. And yes, we'll gradually transition into microservice related questions as part of the same series. So turn on your notification and stay tuned for more videos. But before we get started, if you have not checked out previous videos, then be sure to do that for a solid foundation. Okay? Alright. So without any further delay, let's get started. So let's begin with our first question, that is, how will you handle auditing in your application? Okay. So before you answer to the interviewer how to implement it, first you should give some high level overview about what is auditing and why it is a key aspect for every project. So let me show you with example why do we need auditing. Then we will understand the importance of it. Then we will slowly implement and enable auditing for our application. So assume I have one item entity which is inventory item table. Now I have also created the controller for it called item controller. Now let's add few item and then we'll update them. Let's see the main purpose of using auditing. So this is the endpoint to add the item. This is for get, then update and delete. All the CRUD API I have defined in the item controller. Now let's go to the Swagger. This is what item add, which is nothing post. It will simply add the object to the database. Now I'll click on execute. It added the record for me. Order ID, name, category, quantity, and source system. Now if you'll go and check in your database, you will find the record. Now what happened? This iPhone 16 having 10 quantity in inventory system. Now assume some other person trying to do some update on it. Okay, based on this number only, your catalog service will display the quantity while you will purchase the order, right? Now some user came and he's trying to do some modification. So what I will do, let's go to the update API for item ID 1, then change the request body. Let's say the same product, that user is trying to reduce the quantity in inventory table. Now if I'll click execute, it got updated. Now let's check in the database. Count is changed to 2. The value initially it was 10. Now someone updated it to the 2. But how will you figure out who did it, why he did it, and when he did it? Right? So if someone doing the change, he should have a valid reason why he did the changes. Not only this item, in real time we are using so many entities and we need to keep track of those entities changes. Otherwise, it's difficult to figure out who did it and why and when. So this information is required for debugging and to understand what happened to that entity, why there is a bug or why there is a issue. So this is the reason you need auditing to enable in your system or in your project. So I believe you get the context of why we need this auditing mechanism, why it is a key aspect for every application, right? Now let's understand how we can enable the auditing or how we can apply auditing in our project. So it's very simple. Spring Framework provided the template to go with the auditing. We no need to use our brain. Rather, we can play with the annotation given by Spring Framework and couple of config classes. Okay, so let's go to the code and we'll enable the auditing for our item entity. So at very first step, you need to enable the auditing for your entity class by using @entity listeners annotation, and this offered by the Spring Framework Data JPA. Fine. Once you have done that, then you want to keep track of your entity changes, right? When it was created, when it was updated, who created it, and who updated last time. That is what something you want to capture. That is what something you want to track for your entity, right? So add this field, and these are the annotation you need to use. Again, these annotation came from Spring Framework.data. So you must need to use this annotation. Okay, so it depends. If you want, you can change the field name, but this is something the annotation you cannot change. So when it was created, when it was last modified, who created, and who modified it. All these things you can define using this annotation. Apart from that, you also need to enable the JPA auditing. So either you can create a config class and annotate this, or you can also do the same thing enable JPA auditing in your main class. Fine. So it's very simple steps. We are not writing our own logic, rather we are just enabling the auditing using annotation. Now what else? Now in the item, we'll find the created at updated at this timestamp. Now who created and who update? How you'll get that information? For that, you will find who is the last logged in user to your application. If you found who is the last logged in user to your application, then you can take his user ID and you can map it, right? Who created or update. So for now, what we can do, there is a implementation, audit our implementation, and that needs to be implement from audit our. Let me open this. So if you observe, audit our MPL implements from this interface. This interface, what it has a get current auditor, nothing get current user. Okay, so you need to override that method and you need to write your own logic to figure out who is the last logged in user. Okay, for now I have hard coded Java Techie, but I will show you how you can get that name or user ID from logged in user. So this is what something you need to define. Otherwise, how will capture who did it, right? For that, you need to figure out the logged in user as a current auditor. For now, let's hardcode it and test the things. So all set. Remember three steps. You need to enable the annotation in entity, define the attribute to track the entity changes, then add this audit our IMPL to capture who is the user ID. Then the last thing, you need to enable the auditing by defining @enable JPA auditing. Okay, these are the four small changes you need to do to enable the auditing. Now let me restart the application. So it started, and if you observe the log, it added these columns. Clear everything. Go to the Swagger. We'll add a new entity. Let's say I will add something, some random value. Now click on execute. The record got inserted. If you'll see this output, created at when the entity was created, when it was last update, and who created it, who updated it. Currently we are seeing Java Techie because we have hard coded in audit our IMPL, right? When we'll fetch it from the logged in user, you will find the correct name. So these four fields what we have defined, we are able to see them. Now if you'll validate the same in your database, can you see here? For second record we enable the auditing. This, then this is the timestamp, created at, updated at, and who did it. Now just remember this time, okay? 10:25, right? Now let me do some modification. Then we'll observe whether this value is getting updated or not. Go to the Swagger, go to the update, ID is 2, change something. Okay, let's say I want to increase the quantity to 1000. Now click on execute, go to your DV. If you observe the current time is 10:25, we have not refreshed the table. Just refresh it. Can you see here? The created at will not change because it will take the first time you insert the record. Created by something, it is same. It will take the first username. Then can you see the update time? There is a 2 second, not 2 second, 2 minute difference, right? And updated by Java Techie since we have hard coded. This is how you can audit changes on your entity. Now you can easily figure out, okay, this is the culprit who did the changes. For him, our manager is scolding us, and when he did it, okay, this time he messed up with the data. Okay, catch him and do whatever you want to do. That is how something you can easily figure it out. Now let's move to the next step. Currently we are hard coding the name, but I don't want to do that. Rather, I want to fetch it from the correct logged in user ID. For that, what we can do? First, we will enable the security, uncomment this. Now, go to the security config. Here you see there are so many controller I have defined to just explain the interview related stuff. So what I want to do? I want to enable the security only for item create and update scenario. Whatever the controller I have, I want to bypass the security for them. So uncomment this. If you see here, I have hard coded two user. I'm not connecting to the DV to just show you the who is the logged in user. It's fine. You can understand. We already did a lot of Spring security video. You can check them how to implement JWT, database authentication authorization, anything you can play with that. Okay. So currently this is the user 1, this is the user 2, and security filter chain I have added. So I'm telling here, if request is coming for add, update and delete to the item with this URL, then only authenticate them. Otherwise, any request, allow all the requests. Just bypass the security flow. Okay, this is what something I have added. Now, what is the next step? You have the security related changes with you, but you want to get the current auditor details, right? For that, what you can do, audit our IMPL rather than hard code it, get it from the security context. So if you'll see here, security context holder, get the context, get the authentication object, then from the authentication get the username, who is the logged in username. That is what something we want to track as part of our auditing. All good, right? Now let's do one thing. Let's test our flow, whether it is taking the current auditor as a current logged in username or not. I'll restart the application. So application started. Let me clear everything. Now just go to the postman. Let's modify the same book entity. Okay. So what we'll do? First, let me get the username and password from the security config. Java Techie we already tried. Admin and admin123. So go to the Swagger. I'll just trigger the execute again. It will ask me the basic authentication, right? So you can try it from the postman. That is fine. I'm directly testing it in the Swagger. So just give the username admin and password admin123. Now click on sign in. You got the response. Okay. Now let's go and check in our database. See the result here. Updated at. See the time 10:35. And who did it? Admin. Now is it taking the current logged in username as a updated by? This way you can easily figure out the culprit. Okay. So this is what something all about auditing, and it's very key aspect to implement in your project. So I believe everyone is using it. I don't need to talk more about it, but yeah, this is how you can implement it. Fine. Now let's move to the next question. Explain different annotation used for auditing. Now if we'll go here in item we are using four attribute: created at, updated at, created by, and updated by. To do that, we have specific annotation at the rate created date, last modified date, and who is the user created by and who is the user modified by. Okay, so you need to play with these annotation. Apart from that, to enable the auditing in entity, you need to use at the rate entity listener annotation. Okay, and you need to enable the auditing using enable JP auditing. This is what the annotation you can use to enable auditing. Now let's move to the next one. How can auditing be applied in a NoSQL database like MongoDB in Spring Boot? Currently, we have added auditing in our MySQL, right? Now, how you can do the same for NoSQL? Is this possible to apply the auditing or not? Yes, same way we can do it. Only the changes I'll show you. Only the changes in annotation. Now, let me add the MongoDB. Now, go to the auditing config. Since we are playing with the NoSQL now, you no need to use the enable JP auditing. Rather, what you can use for NoSQL at the rate enable Mongo auditing. For MongoDB specification, you have this Mongo annotation. Okay, can you see here? Then all the flow or changes will be same as it is. You no need to change anything. You need to define those annotations created by, modified by, created date, modified date, and only changes is here. Okay, so let's comment it out for now. And I will also comment MongoDB because I have not added the data source details of MongoDB, so my application will fail. Fine. Now let's move to the next one. How can we customize auditing in Spring Boot? That is what just to understand. You can customize the auditing by fetching the actual logged in user, and so that you can populate the logged in user as a last modified user. Okay, that is what something we have tested now. Apart from that, interviewer can counter you, hey, whatever you have explained that is absolutely correct. If it is a single entity, I will define these attributes and the auditing will work as expected. But what if my application has 100 entities or 10 entities? Do I need to write all these four attributes in each and every entities? Is this the correct way to do it? Not. Absolutely not. So for that, what you can do, you can create a base entity and then let all your entity to extend from it, so that all these four property will be inherited to those entities. Okay, nothing is there. All these four field, remove this, I don't need. You can add the additional field. We have these four attributes what we have in our item, so I will remove them from item. Now in base entity, if you observe, I have used annotation at the rate mapped superclass. The purpose of using this particular annotation mapped superclass, I don't want to create the table for this base entity. Rather, I want all the property of this particular class to be inherited to the child class who will extend from me. Okay, so that is the reason you need to define at the rate mapped superclass. Then entity listeners, to enable the auditing for entity, you can remove it from here. Then all the lombok and these four annotations. Okay, now what is the next step? Now you need to extend your item class from base entity. That's what the minimum changes you need to do. So if you have 1000 entity, just extend them from this base entity. All good. Now if you observe, there is a warning in at the rate data annotation offered by Lombok. So what it is saying, generating equals hash code implementation but without a call to superclass even though this class does not extend Java lang object. If this is intentional, add call super false to your type. Okay. So what I understand, by default, this Lombok will not generate the equals and hash code method for these properties. So you need to explicitly tell to the Lombok. If you are not using Lombok, well and good. You don't need to add any additional annotation. But if you are using Lombok, Lombok will cry. He won't understand, okay, this is the super class. I need to include the equals and hash code along with this item. Okay. So for that you can do, you just define the equals and hash code and tell that, okay, include the superclass attribute to generate the equal and hash code. Now let's start the application and validate whether it is working or not. So it started. Go here and we'll just update the same book only. I'll reduce the count to 10. Execute. It got updated. Just validate in our database. The time got changed to 10:45. So since it cached my last logged in user, it took the admin only. Here it didn't ask me for re-enter the username and password. Okay, because already I authenticate once. So this is the browser behavior. We know that. Fine. Now let's move to the next one. How do you track entity modification across different users in a microservices architecture? And how can a centralized audit service help with cross service auditing? This is very important to understand. In microservice, if you want to track changes or state of your entity which is being modified by a different system, then you must need to go for centralized audit service. The way we have enabled the auditing for now, that you cannot implement in microservices architecture, because in microservice it follow database per service pattern. Each microservice have their own database to use. Okay, so since all are isolated microservice, for that you can go for distributed audit service mechanism or centralized audit service mechanism. Now imagine you have something called order, or name it item. Okay, you have something called item entity, and this item can be modified by different system. It can be modified by order service, it can be modified by inventory, okay, or it can be modified by dispatch service. Okay, this item or order entity can be modified by different source system: order, inventory, and dispatch. Now how can you figure out this item is being modified which source system and when they did it and what changes you did it? How can you figure it out since each are individual microservices, right? So for that you need to go for centralized auditing service. So nothing to wonder here. It is very simple design pattern which is similar to the event sourcing. You can play with that. Now what you can do, let the order, inventory, and dispatch do the changes, and then simply they will publish the message through Kafka. Okay, now you will create one audit service who will listen to that event from the Kafka. Then we will simply update to the database. Okay, all the three microservices will publish the event change to the Kafka, will create a separate audit service who will listen to that Kafka and update the state of that entity to the database. So this way you can track the entity changes or state of your entity changes in microservice architecture. Okay, so if you see this picture at high level, it is something like this. You have order service, you have inventory service. They will change the entity state change event to the Kafka. Now we will create another service called audit service who will listen to that Kafka and update the data in cloud storage or your database, anything you can use. So the data will be look like this: id, what is the action he did, create, who is the user id who did it, Sam, when he did it, and what is the exact JSON data he added to create it, and what is the db timestamp when he did the operation. Then update, who did it, John, when, this is the time, and what is the data, what he update, you will find the entire payload as a JSON in your table or in your bucket. Okay, this is how you can keep track of your state changes of an specific entity in microservice architecture by using centralized audit service. Fine. Now let's move to the next question, that is, what is transaction management and how it works. Okay, again, this is another favorite interview question on Spring Framework. Trust me, transaction is the best way to judge the candidate whether he really work on the transaction or he is just giving some theory definition. Okay, so using that you can easily catch a person whether he know the transaction in and out or not. Okay, so what do you mean by transaction? Transaction management is a mechanism to execute group of database operation in a single boundary, which will always guarantee data consistency by committing all the changes together or rolling them back entirely in case of any failure. Okay, let me simplify this with one real time example so that you can understand why transaction is important in real time. Okay, imagine you have one account service. Okay, you have something called account service. Now there is a to account, there is a from account. Okay, let's say this is from, this is to. I'll name myself Basant, this is something Sam. Fine. Now I'm using HDFC bank, this guy is using something else. Okay, now I'm sending some amount, I'm transferring amount to whom, Sam. Let's say I'm sending 1,000 rupees. Now what happened, when I send, the amount is deducted from my account. Okay, but somehow there is a trouble in ICICI, the amount is not deposit to his account, Sam's account. Then what will be the problem here? The 1,000 is already minus from my account, but it didn't reach to the Sam. In mid of the way there is a ICICI network issue, so the amount is not deposit to Sam's account, but I lost 1,000, right? Can I ask Sam to, hey, I send you, I don't know whether you receive or not, you give back to me? No, right? So there is a gap. So at the same time, when you are sending the amount to the Sam and if Sam didn't receive it because of any failure, what you can do, you should return the 1,000 rupees to Vasant again. Okay, that can be possible if you run both the operation in a single transaction. Okay, this is the reason, to maintain the data consistency you should go for transaction. Sending 1,000 rupees to Sam, if Sam having some technical issue, revert the or roll back the changes to the Basant again. Okay, this is what the transaction. Now let's go with the same code and we'll understand the behavior in better way. Okay, let's go to the IntelliJ IDEA. I created one account controller. Here I will send amount to from user to user, and what is the amount. Now I have the logic here. It does two things, right? When you will transfer, I will get the sender account who is sending the amount, receiver account who will receive the amount. Then I'm checking if what the amount what sender is trying to send, whether he have the sufficient balance or not. Now what it does, it will deduct that amount from the sender. If I am sending 1000 rupees, it will deduct that amount from my account. Okay, then imagine there is a failure in receiver account. So that is the reason forcefully I am throwing some exception. Now once receiver receive the amount, it will add that, it will update that account table. Hey, you received 1000, earlier you have 5000, now you receive 1000, now you total have the 6000. I will update your database. Okay, but here sender is sending, receiver is receiving. In middle there is some exception, technical failure, assume it. Now what will be the problem? If I'll run this application, how it will work, that is what we just want to validate. Okay, now let's see, let's check the database. Okay, Basant and Sam, I'm having 9,000. Okay, I should take from him because I am having less amount. Okay, I'll ask Sam to give me the amount. He is having 15,000, I'm having 9500, 9,500. Now let's see, if Sam is sending some amount to me, and if in middle there is some error, how the system will behave. Okay, let's go to the browser, go to the account controller, try it out from Sam because he is having 15,000 to me, Basan, my ID is 1, and I don't need much amount, I only need give me the 500. Now if I'll execute it, I got the error because forcefully I am throwing the error. But let's check the database. What is the current amount of Basan? 9,500. What is the current available balance of Sam's? 15,000. So when he sent 500, for him it should be 14,500 and for me it should be 10,000. Right? Now let's validate that. What happened? Sam's amount is deducted. Because of some technical fault, the amount I have not received it. It is not updating to my account. This is a big issue, right? The data is not consistent here. If he is sending something, if I am not receiving it, then the amount should be returned back to him as well. That is how you need to maintain the consistency, right? Now let's understand how we can do that. This is something you can achieve using the transaction. Okay, so to enable the transaction, now the next question, if you'll see here, the next question, how will you handle transaction in your application? So for that, it's very simple. You no need to do anything. Go to the service method where which logic you want to keep in a boundary. Just annotate that at the rate transactional. Okay, so just define transactional. That's enough. Spring will take care everything. If all going good, save everything to the database. If anything goes wrong, roll back everything. Now here, when Sam send me 500, if due to some issue I am not receiving it, return the amount to Sam. That is what something we need to maintain the consistency, right? So that is the reason we have added at the rate transactional annotation. Now restart the server and we'll validate it. This is the simplest way to enable the transaction. But if you are not using this data GPA, you are using JDBC, then manually you need to play with the transaction, begin transaction, commit transaction, roll back the transaction, everything you need to do manually. Okay, let's see. It started. Now, what is the current amount he is having? 14,500. I am having 9,500. Again, I will ask him to give me the 500. Already he is in loss, but let's ask him because he is having more amount. So go to the Swagger. I'll same request only, right? From Sam's to Basan 500. Execute the request. There is error 500 internal server error on my side because I am throwing the exception forcefully. Now let's validate the DV. What is the amount he is having? 14,500. I am having 9,500. There is no update happened yet, right? Let me refresh this. I'm refreshing many times. Is there any change? Does that 500 deducted from Sam's account? Initially, yes, it deducted, but since there is a application, Spring transaction will roll back everything. He will return the 500 to Sam, saying that okay, there is a issue while you transfer. Okay, this is the reason the transaction is important to maintain the data consistency across your application. Fine. Now let's move to the next question. What are the different type of isolation and propagation? Now again, this is another tricky question from interviewer perspective to know that how strong you are in isolation and propagation and transaction. Okay, so knowing the transaction, okay, this is what the theory, this is how it works, that does not help you. You should know different type of isolation and propagation level in transaction. Now let's understand first what is isolation and what is propagation. Then we'll deep dive to different level of isolation and propagation. Okay, so first let's understand isolation. Now what do you mean by isolation? Isolation means, let's say you have some method, okay, book movie ticket. Now here you have implemented the transaction. Now assume two thread 1 and thread 2, th, two thread trying to book the ticket at the same time where you have implemented the transaction. Now what data this thread 1 or user 1 did the changes, how you want that to reflect to the thread 2, user 2. That is what something you can handle using isolation. Now for example, there is 10 ticket available. Thread 1 is trying to book 4 ticket. Now whether you want to display to user 2 or thread 2, hey, there is 6 ticket available, or hey, there is all 10 ticket available. How you want this thread to get the value from thread 1 when they both are working on the same transaction. Okay, this is what something you can handle using isolation. Now if you see, there are different type of isolation. If you go to the code and if you will go to the transactional annotation, type here isolation, then you will find different isolation label. See here, default, read uncommitted, read committed, repeatable read, and serializable. So each isolation label have their own purpose to serve. You need to understand each and every isolation label. Okay, at high level, I give you the context. What do you mean by isolation? If two thread accessing the method which is applied transaction, how you want to reflect the data between these two thread, that is what something you can achieve using isolation. Now these are the different type of isolation, read uncommitted and these things. So I don't want to make this video more lengthy, rather recently I have uploaded different type of isolation and propagation. So I would strongly suggest you to go to my YouTube channel, type simply transaction, you can find the recent video, Spring Boot transaction management real time inventory system. Now if you'll see here, you'll find the transaction isolation and transaction propagation. Each and every isolation and propagation I explained in a detailed way with a real time example. So I believe you'll get the real context of isolation and propagation, and you no need to remember the theory. You just give a try to these two video. Definitely you will enjoy it. And let me know in a comment section if you didn't find it helpful. Okay, so just go through these two video. So if I'll include different type of isolation and propagation in this interview QA video, the video duration will be more. So that is the reason I am redirecting you guys to check out if you are interested on isolation and propagation. Fine. Now let's move to the next one, that is different type of propagation. Okay, first we should know what is propagation. So if you'll understand propagation, propagation is something, let's say you have a method called m1 and you have applied the transaction here. Now you have, okay, let me write like this. Now you have another method called m2. Now what happened? You are calling this m2 from m1. In m1 you have applied the transaction. Now how you want your m2 to behave? In m1, if there is any failure, do you want your m2 method which you call inside the m1 method to execute as it is? Or if there is any failure, do you want your m2 method to fail or roll back everything? Then same for m2. Now if m2 and m1, if anything goes wrong on m2, do you want to continue? Or if anything goes wrong into m2, you want to roll back everything? These kind of different permutation combination to manage the transaction method, if it is invoke inside a transaction method, how you want to deal with that. That is what all about propagation. Now if you will go to the code and if you will go to your service, type propagation, you can find there are different type of propagation: required, supports, mandatory, required new, not supported, never, nested. Again, all are not used in industry, but few of them are using. I mean, majority of the project is using few of them. So you can find them from my video about the propagation. Okay, fine. Now let's move to the next point. That is, can we use transaction in private methods? This is very interesting question. Spring transaction will not work on private method because internally Spring transaction use the AOP proxy to apply the transaction on target method. But if you will define the method as a private, then that won't visible to the proxy. Okay, so when I'm saying proxy, I don't want to confuse you. Let me tell you at high level, when you apply the transactional annotation on your method, how Spring deal with it. Okay, so for example, go to the account service. For this account service, for this transfer method, you have annotated the transactional, right? Now let me define one private method here. Private void do something. Now here also I will apply the transaction. Now my question is, will it work? No. If no, why? Let me tell you. This is the account service class. To apply the transaction, Spring Framework internally use AOP proxy. So what it will does, let me create a class so that you can understand. It will create where it is in service, right? It will create a proxy class, something like this, your service append with proxy, then CG leave, something like that. Okay, it create a proxy class. Then in that proxy class, it will extend that class from your target class where you want to apply the transaction. That is nothing your account service. Okay, then it will ask you to override the method. So in this class, account service class, what it will does, it will keep the reference of target class, which is nothing your account service. Okay, let's say target for your understanding. Now create a constructor. Now it will override your method. What is that method? Transfer. it will call the super.transfer, but before that, what it does, it will begin the transaction. Fine, don't make it super, just use target the transfer, because already we have the target bean with us or target class with us. It will begin the transaction by using transaction dot get transaction or current transaction, whatever the method it has. Then it will execute your thing. It will keep in a try catch. If there is any error, it will simply roll back. Okay, better let me write the code in proper way so you can understand. Try catch. So here it will begin the transaction. There is some exception, keep the parent class. If there is some exception, then roll back the transaction. Okay, this is what something Spring internally use. It create a proxy class, it extend from your target class, then it override the method. Before call the method, it apply the transaction. If there is any exception, he roll back the transaction. This is the simple thing Spring does under the hood. Now tell me one thing, since I have defined my method as a private, do something, will it visible to this proxy class? Will I able to override a private method, do something? No, right? Since the scope is private, which is within the scope, you cannot override it. Or Spring AOP proxy cannot override it to apply the transaction. Okay, so this is what something you can convince to the interviewer to explain the internals of how it create the proxy and how the things work, why the private method will not visible to the proxy class. This is not the only thing about the transaction internal works. I will come up with a dedicated video about how Spring transaction internally works. Okay, we'll debug the code like the way we have done for Spring security. We'll debug the same way and we'll understand how internally it works. Okay, that might take some time. Most probably in couple of days I will publish that. But you can remember this is how it works. This is how it create the proxy and play with your target transaction method. Okay, fine. Now let's move to the next question. How will you handle transaction in distributed microservices? This is one of the famous interview question. If you will define, I'm working on microservices architecture. So there are different way you can handle the transaction in distributed system. You can go for saga design pattern. You can go for two-phase commit. You can go for outbox pattern. So out of these three design pattern, I already explained the saga. This is what the saga design pattern. Just give a try. I'll share the link in video description so that you can refer it. I have done this using Webflux. If you guys want me to do the saga design pattern again with traditional code, do let me know in a comment section. I'll come up with saga outbox and two-phase commit. Okay, and since explaining these each and every design pattern will take enough amount of time, and I don't want to drag this QA video to more duration, so I have not covered these design patterns. Okay, again do let me know in a comment section if you want a dedicated video for outbox and two-phase commit pattern. Fine. Now let's move to the next one. Can we use transaction in multiple microservices? Why or why not? Now think about, can we use transaction in multiple microservices? The answer is no. Spring transaction does not work across multiple microservices. As you might have order service and payment service, they are using their own database. Spring transaction is local to one application context and one database transaction. It only works within the boundary of a single service, a single database connection. The transaction specific to the order service is boundary to this point. Okay, and payment service having this boundary. Order service can apply transaction on his own service on his single context. Same for payment service. So once you call another microservice over HTTP or gRPC, then you are outside the transaction boundary. Okay, this is the transaction boundary 1 for order service, for payment service transaction boundary 2. Now from order service you are calling the payment service, and you are expecting if order service fail, do the rollback in payment service. That is not going to happen because both are running in two different transaction boundary. Okay, so this is the good point to understand. If you are using transaction, then that you cannot use across multiple microservices. To use for multiple microservices, as I mentioned, you can go for Saga, two fetch commit, or Outbox design pattern. Okay, so that's all about part 7 QA video. We mostly cover auditing and transaction related questions and answer. In my upcoming videos, we'll cover more questions. Okay, but before that, if you are not aware about previous 6 video part till part 7, you can refer to the YouTube, or if you want, I also have a dedicated Medium blog for it. Spring Boot in-depth interview FAQs, each part and their question. You can find the video link directly from this Medium blog as well. This is the part 1 what we have discussed, and these are the questions we have discussed. To get the answer, you can watch the video. Same for part 2, and list down the questions, 3 and list down the questions. Till 6 it is up to date. I'll update the part 7 as well. Fine. So just go through it, and if you have not followed to Java Techie Medium blog, please do it so that you won't miss any update from my Medium blog. Okay, do let me know in a comment section if you have any doubts or any open questions. That's all about this particular video, guys. Thanks for watching this video. Meet you soon with a new concept.